2022 is turning out to be a great year for electric vehicles globally. Tesla has finally opened Giga Berlin and commenced exporting cars to different parts of Europe. Toyota too has announced its new solid-state battery, which we are going to tell you about in this video. What does Toyota's solid-state battery offer? Will it finally help the Japanese car giant reclaim its lost glory in the world of electric vehicles? Stay tuned as we bring you all the details about the new solid-state battery Toyota just revealed in 2022. If any company was expected to be leading the electric vehicle charge, it should have been Toyota. The company had a nice head start in the EV race. Toyota released the first mass-produced hybrid passenger vehicle, the Prius. The first-generation Prius was equipped with a specially designed VVT-i 1.5-liter gasoline engine and an electric motor. This hybrid system could optimally balance the power of these units to suit the driving conditions. The power split device with a planetary gear set served as continuously variable transmission while also efficiently distributing the engine power to the drivetrain and the generator. The Prius significantly reduced the energy loss through a mechanism to stop the engine when in idle and the regenerative braking system for converting the kinetic energy into electricity when deaccelerating and braking. The front-engine, front-wheel drive sedan could accommodate 5 passengers and featured a uniquely proportioned design, including a relatively tall body, a large cabin, short overhangs, and a centrally located instrument panel. As its exports began in 2000, the Prius caught the attention of environment-conscious American consumers, with many celebrities causing a social phenomenon. It would make it into films and even won the 1997 New Car of the Year and the 1997-98 Car of the Year Japan. Toyota would go on to release the second and third generations of the hybrid Prius. However, Toyota has offered other hybrids, including the RAV4 hybrid. The company announced in 2020 it had sold more than 15 million hybrids, including cars sold under its Lexus luxury brand, and currently sells more than 40 hybrid units globally. With these successes with hybrids, Toyota was quite close to cornering the battery electric vehicle market. Toyota was even an early investor in Tesla, and its shares would have been worth billions today if it had not sold its stock. However, a series of bad top-level decisions sidetracked Toyota, allowing the likes of Tesla to eat its lunch. In fact, in a recent year, Tesla's Model 3 alone was responsible for half of Toyota's customer defection in North America. Toyota decided to pursue fuel cells. It boxed itself into a corner that it had to choose between 1.5 million hybrids and 28,000 fully electric cars. A company executive said Toyota decided to go with the hybrid, claiming hybrids somehow help to prevent carbon emissions better than battery electric vehicles. Meanwhile, Toyota has been accused of taking part in a misinformation campaign against BEVs while promoting hybrids in its home country despite their complexities and increased maintenance. However, Toyota sees the handwriting on the wall and can no longer deny that battery electric vehicles are the future. As such, the Japanese carmaker has poured billions of dollars and countless man-hours into battery research and development. One of the types of battery Toyota has been working on is the solid-state battery. To understand what Toyota is doing with the solid-state batteries, it is essential to know how the lithium-ion battery works. First commercialized in 1991, the lithium-ion battery was initially created for the consumer electronics sector. It quickly lent itself to further applications, eventually becoming standard for all devices requiring a portable, rechargeable battery. It superseded nickel-cadmium and nickel-metal hydride technologies. The principle behind the lithium-ion battery is to circulate electrons by creating a difference in potential between two electrodes, one negative and the other positive, immersed in a conductive ionic liquid called the electrolyte. When the battery is powering a device, the electrons accumulated in the negative electrode are released via an external circuit to travel to the positive electrode. This is the discharging phase. Conversely, when the battery is charging, the energy supplied by the charger sends the electrons back from the positive electrode to the negative. A lithium-ion battery is designed as an assembly of individual battery units or cells connected to each other and monitored by a dedicated electronic circuit. The number of cells, the size of each cell, and the way in which they are arranged determine both the voltage delivered by the battery and its capacity, meaning the amount of electricity it can store. This is generally stated in watt-hours or kilowatt-hours. Solid-state batteries are similarly built but use a solid electrolyte instead of one in a liquid state. These electrolytes can be made from every everyday materials like ceramics or glass. That change in electrolyte makes a considerable change to the battery's capabilities. So what are the benefits Toyota is looking for with the electric vehicles? The first is that solid-state batteries can be smaller and weigh less. Solid-state batteries are capable of delivering 2.5 times more energy density of current lithium-ion tech. This tremendous increase in solid-state batteries' energy density means Toyota can reduce the size and weight of its EV batteries significantly. Higher energy density means that batteries could be much lighter and store the same amount of energy. Weight is a critical concern for mobile power applications, so this is a game changer for Toyota. Its cars will also get longer driving ranges with less weight and space in battery storage. Solid-state batteries will also let Toyota EVs charge very fast. These batteries can work at very high rates of power, and research suggests that they might be able to recharge 4 to 6 times faster than current technologies safely. And this brings us to the next benefit of Toyota's new solid-state battery: safer batteries. The liquid electrolytes used in lithium-ion batteries are extremely volatile and highly flammable. These electrolytes also mustn't be exposed to air. However, Toyota's solid-state batteries contain no liquid parts and will not have this volatile component. So while lithium-ion batteries are subject to events like thermal runaway leading to explosion and fire, the solid electrolytes used in solid-state batteries are non-flammable. They thus present a lower risk of igniting a fire. The battery may still get hot during usage, but there is nothing flammable within it that will catch fire. As a result, Toyota's new solid-state batteries will require fewer safety systems than lithium-ion batteries do. Removing additional electronics can contribute to smaller, lighter-weight battery packages, which further enhances solid-state batteries' energy density. These batteries may not even require an external BMS in certain situations, greatly simplifying their construction. Also, solid-state batteries are much easier to manufacture. Working with a volatile liquid that cannot be exposed to air is a huge challenge that could be eliminated entirely with solid-state battery technology. A solid electrolyte could enable much faster production that uses less material and energy. Now, Toyota is far from being the only company working on solid-state batteries. Samsung, for instance, which doesn't even make electric cars, is joining the race to bring the first solid-state battery to the market. Other companies are Solid Power, QuantumScape, LG Chem, CATL, Panasonic, and more. Fellow car makers include General Motors, Stellantis, Volkswagen, Ford, and again more. However, no company comes close to Toyota in how far they have come with their solid-state battery. Toyota announced a $13.6 billion investment in battery technology, including but not limited to solid-state batteries, spread out between research and development and production equipment. The company is targeting a 200 gigawatt production capacity if there is sufficient demand for it. The solid-state batteries are on some roads now actually engaged in real-world testing. Toyota has produced a solid-state battery-equipped version of its LQ Concept, which it has registered for street use in Japan. The car is used for gathering information about the solid-state battery tech. Toyota has also confirmed how it will roll out the solid-state battery in its cars. During this year's CES Tech Show, Toyota was on hand to talk about its brand-new batteries. In an interview, Gil Pratt, Toyota's chief scientist and head of the Toyota Research Institute, explained how Toyota aims to commercialize its solid-state batteries. Surprisingly, or not surprisingly for jaded Toyota fans, Pratt said that the first Toyotas to receive the new batteries would actually be hybrids instead of fully electric vehicles. That is sure to be disappointing for some people, but Pratt explained Toyota's thinking. He said solid-state batteries are at the moment more expensive to produce, and since hybrids have smaller battery packs than EVs, implementing them in hybrids first will reduce the cost. The other challenge facing solid-state batteries currently is battery life, with repeated charging taking a toll on early prototype batteries. In a hybrid, the smaller battery is charged and recharged far more often, and Pratt suggested that the increased amount of cycling for the batteries will make hybrids a good testbed for the new technology. Let's hear what you think of Toyota's new solid-state battery in the comments section below.